Everyone loves to take a bite of those well-sized apples with desired amount of sweetness and color. But do you know apple trees cannot produce marketable apples by themselves? Each of those apples comes from flowering bud. Each bud can produce around 5 to 7 flowers, and there are hundreds of these buds in each tree. If all the flowers are allowed to mature into fruit, there will be large number of small fruits with lower quality and sugar content. So how do you get those apples that we'd really love to take a bite? It seems less is more. Every year, growers rely on human hand and intelligence to systematically remove unnecessary flowers from apple orchards. Now imagine flower removal by hand from thousands of those trees planted in hundreds of acres of land. This process is highly labor intensive, laborious, and time consuming. In recent years, growers are also facing farm labor shortage that is worsened by ongoing pandemic. This is challenging the sustainable production of one of the most loved fruits in the US and around the world. My PhD research is to understand how humans perform apple flower removal and develop a robotic system that tries to mimic this process. Seems like an easy task, right? But we as humans perform multiple complicated operations just via intuition. We have eyes that take a snapshot of the canopy. Then the brain computes which flower to remove, from where, and to what extent. We have two arms to reach to the desired location and fingers to remove the flowers. All these happen in a couple of seconds. To mimic this process, I have two cameras acting like eyes, robotic arm acting like human arm, and end-effector acting like fingers. This end-effector has rotating strings that remove flowers on its way. Now, the most critical part is how to bind all these hardware systems together by an intelligent system so that they can understand the environment and make situational decisions. For this, I use artificial intelligence method. Similar to human learning approach, the artificial intelligence methods learn by examples. By providing different examples of apple canopy images, I trained the artificial intelligence algorithm to determine where the flower clusters are and how many flowers are there in each of those clusters. Figure in the bottom middle is the result from our algorithm. We achieved around 86% accuracy to segment flower cluster regions and count number of flowers. Once the flower cluster segmentation and counting is available, the robotic arm can reach to the desired location and remove flowers as needed. Currently, the robotic arm, end-effector, camera system, and the artificial intelligence system are being integrated and tested in lab. The integrated system will also be taken to commercial apple orchard for field evaluation in this coming season. The proposed robotic blossom thinning system, when successful, will assist in sustainable apple fruit production for keeping those grocery store shelves filled with apples for future generations.